Okay, hi everyone. So for people joining this live stream, this is a design review about calculus and algebra functionality for the upcoming version of Wolfram language. And I think we have looked at some of this already, and there's some new stuff to look at here. Is that right, Roger?
Yeah, it's the same stuff. I think we didn't look at everything, and we need to settle the names at the top. We need to, if you go down past special functions to the algebra section, we have Adam here today too. We can discuss cylindrical formula, which we didn't get to last time. The other two items are not making it, probably. And there would be no design changes anyway.
The minimize, maximize.
Mm-hmm.
That's a pity. Okay.
It's just, I mean, they're just, yes, we'll see. I mean,
okay.
They'll make it eventually, but maybe not this release.
So wait a minute, did we look at asymptotic expectation and so on yet?
I think you just glanced over it, but we can look at that.
Okay. All right. Let's look at this first. All right, what is this?
It's a representation for the cylindrical algebraic formula. So it's a representation for the result of computing cylindrical decomposition, so that it can be used in other computations, and the computations know that the input is a cylindrical formula, because it's after you make a Boolean formula out of it, you cannot really tell that it's a cylindrical formula.
Okay, so cylindrical decomposition normally will just give this kind of form, right?
Yes.
That is a decomposition in terms of, what is it, these semi-algebraic sets or something?
So it's a decomposition of semi-algebraic sets in terms into cells that are bounded by algebraic functions.
But that decomposition satisfies certain strict contracts for it to be a such decomposition. So it needs to be cylindrical, meaning that the variables that occur at the bounds, even that first example shows that the bounds include variables that are previous variables. So the bounds include x.
Okay, so what can generate a cylindrical formula?
Only these guys.
Cylindrical formula. So cylindrical formula is an input, creates it and represents it.
Okay, and what functions eat it?
Reduce, resolve, find instance, solve, optimization functions.
And everything that
and
everything that
itself.
Yeah, but also everything that indirectly uses like the geometry functionality, if you integrate over piecewise bool things.
Okay, so what is it in the sense that, does it have tentacles hanging out, which are its variables, or is it just a, how should I think about this object?
It's a formula, so the variables are outside, so you see that it's a formula in variables that are listed later.
Which means that it's true or false. If you give numeric values to those, it will be true or false, Stephen. If you give...
Why on earth aren't you calling this cylindrical formula function, putting the variables first, and having it walk and talk like a function?
Because it's the primary goal isn't to evaluate it to true false. The primary goal is to, like if you do Boolean operations on it, if you have those things coming in, you can do more operations on it.
No, I understand that. But I mean, so
it doesn't have to be the variable. So the cylindrical formula object itself is a Boolean function. So the second argument can contain any expressions in it. So instead of x, y, z, it could be x squared, y minus 1, z plus 7.
What does it mean then? If this, but then if you feed it specific arguments there, that will be what? What will those specific arguments be?
If you replace in the result, if you replace x, y, z with specific arguments, you get true or false.
I'm confused. Look.
Yeah, I think that I think Adam. So Adam meant that in the formula, when you get the cylindrical formula, the arguments there, you can use formulas for the x, y, and z.
Okay, but what about here? If I do this, what's
no. It's
Yeah, that's what I think
those
was
are
the
just
misunderstanding.
it's the constructor. So this is the constructor, the input format that constructs cylindrical formula. Once you have cylindrical formula, the cylindrical formula object is
right.
not
But
equal
so the way
to
I
its
should
input.
think about this is if I say reduce x equals x, I get true. And I don't understand why this thing isn't cylindrical decomposition function. X, Y, Z. X squared, blah, 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 blah.
Well, it doesn't need XYZ after it's done.
I mean, after it's done.
Cylindrical formula object doesn't contain any variables anymore. The variables are outside. They have been given to the input to construct cylindrical formula. So cylindrical formula is a constructor.
Okay, so it's a function. Okay, I see. But that would be fine. I mean, in this case here, the return value here could be something that is just like an opaque function object that then just gets applied to things.
Right. That's what cylindrical formula does.
No, I understand that. But so what I'm saying is that I'm claiming the correct name is cylindrical decomposition function because it is a function. Now, the fact that it processes itself to not contain this literal stuff inside is its business. But it acts like a cylindrical decomposition function, does it not?
Yes, afterwards, or it actually, so it gives you, no, it's not quite the same. See, you input the cylindrical formula with XYZ and you get the XYZ on the outside. You don't have to apply it. You get the original variables. So you get the cylindrical formula, which is a
that's really weird.
Which is a pure function, and you
that's really weird. That's really weird.
It's really convenient if you look at the example how it works at the workflows. So it's just it produces the formula. You don't really want to get a pure function and then have to apply to something.
What the heck is this? What the heck is this? No, come on. This can't work like this. Look, there's either f of x, y here. You can't just say f.
Well, f is an expression somewhere.
Oh, it has the. Oh my God, this is so freaking confusing. Okay. Roger, I don't think this is right. I don't think this is right. I don't think it's right. I think it's scrambled.
Yeah, well, so we have to. So I think that once we see more use cases, it's easier to accept. But we do need these efficient representations.
That may be, but I don't think this is correctly designed.
Yeah,
So let's go through what the design has to achieve. Okay, what you're trying to do is you want to have, if I could just write for you a thing that said tag of this polynomial, would you be happy, or are you actually processing the innards of that cylindrical formula?
It's processing, so it's not, it doesn't contain the polynomial anymore. You can look at the input form. It's complicated, but it doesn't have any variables in it or polynomial.
Rather horrible, if you ask me. But anyway,
well, it's not for looking at. Well, this is the processed. It's computed cylindrical decomposition. This is the processed thing.
This is even more bizarre. I can't even ask what that is.
It's something that's specifically put there so that you don't edit it and expect it to work, because
there's a bit of a hack tower here. So okay, so I'm just trying to understand here. So this thing stands in for a Boolean expression involving polynomials, correct? Or involving algebraic functions.
Yes.
That is its role.
Yes, and it stands for for a specifically formatted expression that has certain properties that are not easy to check. So if you get an expression that
Oh yeah, I get all of that, but I'm trying to understand what it is. Okay?
Okay.
So let's get an analogy. So I mean, let's say we have an algebraic number or a root object.
I think
Okay,
a
so
Boolean function is the design analogy to this.
okay.
If you look at the Boolean function object.
All right, but here, if I take one of those things, well, okay, let's look at Boolean function. Notice it does have the word function in its name.
Because it really is a function.
I know.
That's the difference.
I know. You apply it to arguments and it does its thing, right? And
actually, you can also apply cylindrical formula to arguments and does its thing. So it's very similar. And
I know. I understand.
Okay.
I got it. Yeah, I got it. And it's true or false.
Yes.
This is totally frigging weird, and we've never done it this way anywhere else. Of having something turn into a function of arguments that were inside it. Now, having said we've never done anything like that before, I think maybe there's a counterexample.
Yeah.
That's
No,
a
but
bad
if you do
example.
f there instead of fx, the second argument.
No, I was trying to do something different here. Let me try and do this. That's not a good example either. But you see, the f of x, if I could do this with an interpolating function, let's see, what happens with nd solve?
It behaves the same way.
No, but what does it do? What does it put an interpolating function? Does it have...
Yeah, when you have f of x, you get interpolating function of x.
Yeah, that's what I thought, which is behaves the same way that the cylindrical thing does.
Yeah.
Oops. Okay, you got a precedent here. This is a precedent, right?
Yeah,
What this
right.
is doing.
Yes.
Okay.
But I think Boolean function does that too, doesn't it?
Yeah. Well, it's
No, it doesn't do it. It doesn't need to do it.
some inputs.
I think they're a variable case.
If you do the last one with form, I think you will get something with.
No, you get that, but you don't get a raw Boolean function applied.
Look at the example that's at the bottom. Yeah, this x
Convert x or Boolean function. Yeah, I guess.
That's Boolean convert.
Right. So the
To a Boolean
formula
function. It's not a self-computing thing.
Right. So it sort of does.
So you know, it's sort of a pity then that cylindrical decomposition can't return one of these objects.
Yes. Which
yes, except that it's used already, and
I know. So one of the principles of design is figure out what the right design is first, and then see if we can make a bridge from what we're currently doing to that correct design. Okay? So imagine that we could rewrite cylindrical decomposition. What would we want it to do? Okay, just imagine that we had a function called cylindrical algebraic decomposition, just for fun.
we did.
I know. Just for fun, let's imagine we had such a function. And that then it could return different values than our current cylindrical decomposition function. And it could return a, cylindrical algebraic function. Okay? Just imagine that's how it worked. Would that make sense?
Yeah, that would make sense.
But we will still need the page that documents this format, the cylindrical formula,
Oh, yeah.
whatever the name it is.
Absolutely. But what I'm suggesting then is that, you know, given that we think we would much prefer to return, boy, it's been around a while, to return, is that the right name, cylindrical algebraic function? Would that be the correct name for this thing?
It's usually called formula because it's Boolean valued. So formula would be a Boolean valued function.
No, I don't care. I mean, it's just like it's a Boolean formula too, but we still call it Boolean function because it acts as a function.
Yeah. So I guess from this point of view, yes, it should be function.
But I mean, the question is, to me, is there any other design change we might like to make to cylindrical decomposition?
Well, I mean, in its formula, output is also useful. So it's like both outputs are useful for different things.
Well, I mean, one is the normal of the other, right?
One is the normal of the other right now, yeah. Yeah. So,
all right, so what you were trying to do, oh boy, Roger, help me out here.
Yeah, so if we do that, if we modify cylindrical decomposition, we need an argument that says format, which we could do. So I went down that. It's a possibility, except we added in these topological operations. And if it just been,
yeah.
Okay, so
where else would you put them? I mean, imagine you were renaming the thing. So it's called cylindrical algebraic decomposition. So all current designs are off the table.
Well,
that's what I'm saying.
I think we would still have this topological problem, actually.
Okay, so explain what are these topological things?
They give you other outputs, basically. They give you the boundary output, the closure of the input set.
No, so why, I don't understand why you're not just calling it boundary formula or boundary expression and then boundary as the, you know, you could do something like that, where this is the case that corresponds to the actual explicit expression, and the other one is, you know, I mean, it might even be boundary expression, boundary function.
Well, I guess we could name this second thing to not be, I mean, it is called op, but it doesn't have to be topological operation. It just says
it just says what the format is.
Oh yeah, what it computes.
Right.
And part of that, we just then need to come up with a name for.
Well, what I'm suggesting here is that there are two cases: boundary expression and boundary function.
Right, but normally it comes up with something that's equivalent to input, which is the same. We just need a name for that.
What do you mean by equivalent?
Expression and function without anything.
Expression and function, I guess.
Yeah, that'd be fine.
Yeah, and so then that's actually not a bad solution. You know, even for just using that for cylindrical decomposition, extending that, redocument op a little bit, and that says what you get. And then we just double the length of that list, so it's instead of
cylindrical algebraic function is
17, 14.
New object.
So it will still be a
algebraic function would be a new symbol that just gets generated by cylindrical decomposition.
Yes.
Taking input.
Does it make any sense to call it cylindrical function, or is that stupid?
Cylindrical function.
I mean, did we misname cylindrical decomposition?
Because it's usually called cylindrical algebraic decomposition.
I have to say, my suspicion is that we should document cylindrical decomposition as cylindrical algebraic decomposition, have it by default return cylindrical algebraic functions, and just sort of say this has been cylindrical decomposition has been superseded. I don't know. I mean, maybe that's silly. I just feel like cylindrical decomposition hasn't exactly been used. It's used internally a lot, but I doubt it's that much used in the outside world.
It is used, so
okay, well, fine, but I mean, it'll be supported forever, right? That name is going to get supported forever, but the question is whether the default.
I don't think we need to rename it, Stephen. We can upgrade the design of it to accommodate this.
Okay, but then what are we going to call the function version?
Whatever we want. Cylindrical function is
well,
kind of okay.
Cylindrical algebraic function actually with the algebraic insight does look better.
Yeah, but then we can't have cylindrical decomposition and
Why not?
Cylindrical algebraic function. Well, I think we'd have to call it cylindrical decomposition function.
We could have cylindrical decomposition function, but that would be,
yeah, we could be that.
All right, so then the decision is cylindrical decomposition by default still gives an expression, but cylindrical decomposition with third argument function returns a cylindrical decomposition function.
Mm-hmm.
Okay, and that cylindrical decomposition function has, like a classifier function or something, has no documented internal form. It's just an opaque thing that eats arguments and gets, and gives results, right? Right?
Yeah, we can document it as being constructed by cylindrical decomposition. So we undocument its own construction.
And then the examples for use of it go to the page of cylindrical decomposition.
Yes. No, I mean we can still have examples that use the cylindrical decomposition that generate it.
Use cylindrical decomposition to compute with it on the page of cylindrical function. Yes.
Yes.
Cylindrical decomposition function.
Cylindrical decomposition function.
Okay. All right. I think we nailed this one. Okay. Do I have to look at the solve thing with taking assumptions? Is that controversial or not?
No, not particularly.
I thought it had taken assumptions for like a decade.
Oh, Devendra.
Asymptotic with respect to what?
Call boxes. There's something wrong with the call box. We have to fix that. I don't know how you made it, but
okay, I'll fix
wrong.
that. Okay.
See, the indentation is wrong.
Yes. Okay. Fine. I'll check that.
It's very weird to me that you have to have an asymptotic everything. I mean, I admit that it's almost like it's a decorator of asymptotic of expectation.
Yeah, but we built, okay, so the alternative solution that we have, but I really think that these guys deserve it, both expectation and probability. What we did for integral transforms is we didn't build asymptotic Laplace transform and asymptotic inverse Laplace transform and the other 30 such functions. But what you use is asymptotic of inactive of that form.
Yeah, it's not the best solution.
No.
I mean, I think a better solution would be something that says, let's imagine, okay?
You can do that, but, oh, no, what are you doing? No. No.
Why not? I mean, possibly this isn't a good idea, but just explain why.
So this is instead of, this is the equivalent. Then for Laplace transform, we can have all other transforms, basically, is what you intend.
Yeah. Laplace anything. I mean, this would be, you could put anything in there. You could put an integral in there if you wanted to.
Why? How?
Oh, look.
How does it relate to the T and the S?
No, it doesn't. I'm not saying that. I'm saying this, okay? There, right? It's saying this is an integral, but it's saying This is a modifier of the integral.
That looks worse than asymptotic of something that you know.
Well, except you have to use an active in the asymptotic.
Well, you can also avoid using it, but then you're going to pay the cost of trying to solve it exactly first.
Devendra was going to say something.
Yeah, I'm just going to say that just like if we did n of dsolve, you get n dsolve failed. So the asymptotic is a wrapper for all these functions.
I know.
So I think that seems to have worked well.
All
But
right.
yeah.
Okay, but nevertheless, you're trying to introduce particular asymptotic x function.
These are the last ones we think are worth it.
Mm-hmm.
Because I think that these, both expectation and probability, are high traffic solvers. And they can benefit from the specific analysis done to them.
Yes.
Because a lot of the asymptotics is actually developed for just probability and statistics.
All right, okay, so let's take a look at this one. By the way, I wouldn't use ... there. Like it'll confuse the, I would use, var tilde dist there. I think it'll confuse the syntax system if you do that.
Okay.
Okay, nice enough. Asymptotic probability. It's just a kind of weird name, asymptotic probability. To suggest it's a Markov chain and it's been running for a long time. And what's its asymptotic probability?
That doesn't suggest that to me.
By the way, I assume you have the spell checker turned on when you're authoring these pages.
Sorry, I'll just check that. Sorry. Yeah.
No. I'm just saying.
Yes.
I mean,
yes, yes.
Okay. Okay. So I think did we look at these, or do we need to look at these?
We did look at them, and
okay. All right, let's go back to these horrors. Okay, so I think what we've agreed is that this will be function injective. Is that right?
That was from yesterday, so I don't think the people here have heard that yet.
So it goes along with function discontinuities, function meromorphic, etc., etc., etc. Parmenides on our live stream is commenting that asymptotes are underrated, and that ever since Newton they seem to have been underrated.
I agree with him.
But do we have asymptotes here anywhere?
No. I mean, asymptotes are usually in visualization functions.
Yeah, I understand, but you can compute the asymptotes of a function.
Yeah. I mean, we have it listed as an application example for asymptotics. Right. You divide it by x.
All right. Well, so if we're okay with function injective, function analytic, function meromorphic, function discontinuities, function singularities, those all seem reasonable. Now there's this strictness thing. What does that mean again?
So it requires strictly monotonic or strictly positive instead of weakly positive and non-decreasing.
What do we think about different names for this? Strict condition. You can't say strictness arrow true or false.
I think strict condition is okay.
Conditions, yeah.
Unlikely to be clobbering something else.
Strict. Does it make, I mean, it's like, it's like a strictly applied condition is the full thing that you're doing.
No, it uses strict inequalities instead of
Strict
non-strict
version of a condition.
inequalities.
Say it again.
Strict version of a condition. Oh, sorry.
It uses strict inequalities instead of non-strict inequalities.
Well, why don't we say that? Why don't we just call it that? Then we'd know what it was. And I wouldn't have to ask the question.
Right.
Strict inequalities singular or strict inequalities plural? Strict inequalities plural, I think, is right.
Mhm.
Sounds good to me. Okay, this leaves over then polynomial expression Q. Okay, what's the difference between that and polynomial Q?
It's a, so polynomial Q is sometimes trying to figure out, it's using rat input to convert the expression to something like a rational function. It's using rat input, the internal thing that we have for polynomializing or rationalizing things.
It's a Kelly-Roach production that's trying to recognize like trigonometric polynomials as polynomials.
Right. Actually, I think it works only for exponentials. Maybe just for trigonometry.
Oh, I remember that.
Okay. That means that it's well,
it's potentially slow and gives you surprising.
All right. So why isn't it being given a performance goal?
Well, it's not really about performance, but about performance goal should not make the output different, like true instead of false, or vice versa.
I think it should be an option to polynomial Q. I think you're sliding down a slippery slope of the 17 ways something could be or not be a polynomial.
Right. So this was sort of function accompanying rational expression Q, which is the new thing because we don't have rational function Q or whatever it would be called, like analog of polynomial. And so rational expression Q will do this syntactic check.
This is a mess. Okay, let's call a spade a spade. Basically, polynomial Q, a reasonable function, you say has the wrong functionality. So you're introducing polynomial expression Q. Rational expression Q would be an okay name for a rational expression. Or rational function. I mean, would it normally, if it wasn't for these other constraints, would you call it rational function Q?
Probably rational expression. So rational function Q might expect that you decide whether something is an actual rational function, even if it's not written as a rational function. And these are syntactic checks.
Oh, okay, that's a decent argument. No, you can't use the. If you're going to give this argument, the first line of the usage says gives true if x is structurally has structurally the form of a polynomial in x. Is an expression that is structurally a polynomial in x.
Yes.
Yeah, we could write that up there.
Yes.
It should definitely say it somewhere.
Yeah, I would put it there because that way it explains why it isn't polynomial Q.
We can do that.
And polynomial Q should say, and this doesn't even have a C also to polynomial Q, which it should, right?
Yes,
Obviously.
I don't think it has any COs.
Okay, okay. So fine. So this is a struct. Okay, I'm reluctantly recanting on this, but it would be nice to understand what polynomial Q's precise contract is.
We would like to that too. We are mystified.
Well, look at the code.
Well,
so it's like polynomial expression, except that it uses rat input, and then you have to explain what rat input does.
Exactly. It's fascinating rat input, though. I can tell you.
It's ratting out the expression.
One thing, Stephen, I think Kelly Roach must have been a physicist.
No,
because
no.
Because I wrote some functionality that I realized it was somehow hidden in rat input, but it would be super hard to get to. And when I looked at the source code, tried to understand what the heck was going on, he used bosons and other things, fermions and bosons, to explain what's going on in code.
Weird. Well, yes. I can't.
So I was thinking,
explain that.
It's like, what?
Yeah, I can't explain that. Okay. All right. I'm now trying to answer that question, actually. Huh. That's right. I remember what it was interesting, computational linguistics. Right. Okay.
Oh no, did I send you down a physics hole?
No, I'm just answering the question. Was that developer a physicist? And the answer was no.
Okay.
Okay. Right. Well, what else do we have to figure out here?
I think that concludes it. Could you take one scan all the way down?
Yep. This is all lovely, but I don't think there's anything for me here.
No, it's more.
And well, I see. Those are just new pages.
Yeah. They will go. They will.
If you have a heuristic for understanding when do I use trig expand, trig reduce, trig factor, that would be wonderful.
Yeah, that's back to the same rat input, actually.
All these functions, the rats are running onto the ship, so to speak.
Yes.
Okay. Okay, great. Should I just look for fun at one Lamé function just to admire that we finally got this? Does it have any kind of weird order conventions like Jacobi elliptics do and things?
Order in sense of, there's the odd and even Lamé functions. So the second argument over there is kind of odd or even, and then you get different behavior, if that's what you're asking.
No, it's not what I'm asking. I'm asking, there are different argument conventions, right? For what this means, Sn z vertical bar m, right? Aren't there different ways of writing the arguments using, isn't that what the what's it called, Jacobi amplitude or something converts between them?
Right. I don't think there's right away. The only thing that did affect us is should use an m or a k, because you could either write your elliptics in terms of m or k, and you're using m for consistency.
Okay, but I mean, but the K means something different from the M. Is that correct?
Yes, exactly. It's like roughly
I see.
like a square root kind of thing, So
Well, you have to document that. I don't see that documented here.
okay, we'll do that.
Also, spheroconal is really a thing. You better get it put in the spelling corrector.
Okay, fine. It's
And does
used on.
I mean, does it have a hyphen, or is that hyphen only from 100 years ago?
No, we checked DLMF, the digital library. That's where we got this one from. So I think it's okay, but I can still check again.
I would. Look, there are two choices. Either it's spelled right, in which case it should be an as spelling corrector.
Yes.
Or, okay, so I'm seeing on the web lots of, I'm not seeing a very convincing story here. But spheroconal is written without yes. So it's written often without the hyphen, and I would remove the hyphen.
Okay, fine, we'll do that.
Words that start hyphenated end unhyphenated 25 to 50 years later.
Okay.
Yeah. So we converging to German.
I don't know. Anyway, so you're saying the new is an integer?
The second argument J is an integer, and if J is odd, you might behave like, let's say, cosine, and if J is even, then you get sine. Like so each of these.
It's like the elliptic thetas. I mean, it's that kind of pick a number, but it's got to be in this set, or it's an arbitrary integer.
It could either be odd or even. It's a bit like elliptic theta, but if you didn't do this, then you'd have 4 kinds of Lamé functions. You'd have Lamé C.
Oh, yeah,
even.
I got it.
Yeah.
Why is the argument order the way you're writing it?
I'm not sure we didn't see this at any place, but maybe just it's a question how it typeset. So
No. I'm asking the question. Usually, when there's a sort of major switching parameter, it comes first.
Okay.
I mean, in other words, I don't know. You got to look at how people write Lamé functions. I mean, why don't I see Lamé function ECJ new? Okay, so the convention, if that's how it's written, I believe that is the convention we use, that the subscript comes first.
Yes, exactly. And so people don't even use even odd. I mean, they always separate them out, but we are trying to combine them for
so we've invented that idea of putting the superscript with a J. Is that correct?
Yes.
But what's the difference in Lamé C and Lamé S? If isn't S the sine-like and C the cosine-like?
No, you'd think that, but they just correspond to different Lamé eigenvalues. So Lamé C corresponds to eigenvalue, Lamé eigenvalue A, and Lamé S eigenvalue B. And then within C and S, you still have a kind of bifurcation of sine-like and cosine-like behavior. So it's not like they're
What happens to all our numeric function things when you have that weird second argument that has to be an integer?
So how it behaves with n values, you mean, or?
Yes.
I think that has to be custom done.
Yeah, I think
in that case.
Yes.
To prevent that.
You know, Brian is making an interesting suggestion on our live stream that we should have a link to MathWorld for background on these concepts. I'm not sure how often we do that. I think we started off actually building background things. Actually, Eric, who built MathWorld, also built a bunch of those background things. But the idea of just linking straight to background articles in MathWorld, why haven't we done that?
I thought we had done that. But there was like systematic.
Okay, well, maybe so.
But the question is how we keep it up, because I think that might have been part of a linking project.
A crosslinks project. Yeah. Well, okay, so that is worth asking then of Brian and the Brian V.
Yeah. So if you look at sine, for instance, there's a link to MathWorld and the function site.
Okay, fine. So the question is, I mean, that was done in the crosslinks project, but the crosslinks project was ended because we'd finished all the crosslinking.
Right.
I'm not sure if that process was correctly continued.
That's exactly what I was thinking too. We probably have to.
So ask the new docs group. It's still called new docs in the same way that it's called new pence in England, the currency, even though it's been like that for whatever 50 years.
Right.
Okay. I mean, I would check what happens with the numeric thing, with putting that thing second.
Yeah, we should.
I'm not certain about
Okay,
that.
I'll check that.
Okay. Looking good. Okay, off we go then. I think this is some. Let's declare victory. Look forward to seeing this stuff migrate from prototype to the main build.
Thank you very much.
Thank you, Stephen.
Okay.